Let's take a quick look at view pagers. A view pager is a view in Android that allows a user to use the swipe gesture to move through a collection of fragments. So a simple and common use case might be a photo display application where the application has a collection of photographs, and to allow the user to view those photographs one at a time, you can have a fragment display one photograph each, or a collection of fragment instances where we're displaying one photograph on each fragment. And then the user can, using the swipe gesture, move between photographs. And we can also programmatically jump to any specific photograph while still maintaining the order of the photographs that the user can then continue to swipe through. So let's look at a very simple example of the view pager. And we will start by looking at and testing out a simple fragment. So here we have a fragment called text fragment. The text fragment is currently just doing the basics. It has a layout file called fragment text. This layout file contains a text view with the ID text view inside a constraint layout. It's a simple enough layout where we could have just made the text view be the root element, but we'll just continue working with what we have here. The text fragment itself, again, right now doesn't do anything outside of the basic templatized code that was generated. So we have a factory method that accepts a string value. It then stores that string value in a property called display value via the onCreate function. And we inflate the layout in the onCreate view. So the goal of this text fragment is simply to take this value that is passed in via the factory method and display it in this text view. So we can do that. The proper place to do that would be simply to override the fragments on view created function. And inside this view object, which is the layout, so in our case, this is going to be the constraint layout, the root element, we can inspect that view and find the text view contained therein, which will be r.id.textView. That was the name. And then apply the text value display value. So that's the property that would have been passed in when the fragment instance was created. So that completes the fragment's basic functionality. We just want to be able to display some text. So now we're going to test this. We're going to test it by attaching this fragment to our activity using the conventional method that we're familiar with. That is, we are going to use a fragment container view to embed the fragment inside the activity. So right now our activity doesn't have anything, and the activity's layout also doesn't contain anything except the basic constraint layout. So what we're going to do is, again, just as a test, we're going to add a fragment container view, which is our standard way to attach a fragment. Here it's telling me that I should select the fragment that is going to be used to display that will be contained inside the fragment. I have to select it. If I don't, Android Studio will not allow me to add the fragment container view using the WYSIWYG editor. I could always go to code and type it in manually, but it's easier for me to just say, okay, like I'm accepting it. I want to use that fragment, but then switch to the code view and simply remove the Android name property that references the fragment. Once I've done that, I still want to make sure that I'm doing everything I'm supposed to do with regards to the constraints and whatever else I want to do for my container. I really wish I could infer constraints, but that so oftentimes doesn't really give me the result I want. So we do it the old-fashioned way. All right, and there is my container. It's a little slow to update the rendering, so that's an interesting observation in the current version of the IDE. So the ID for this fragment container view is fragment container view. I won't change that since I'm just using it to test. And then I'll go to my my activities implementation, and I will get the fragment manager. I will begin a transaction. That transaction is an add, and I'm adding to the container r.id.fragmentContainerView an instance of text fragment, calling the new instance function and passing in a string value. Hello. Having done that, we need to commit. And if all goes well, when we run our application, we should see an attached fragment instance with hello. All right, seems to work. At least the fragment does what it's supposed to do. So what we want to do here now is introduce the ViewPager. And the ViewPager is, first and foremost, its own fragment container. So when we're dealing with a ViewPager, we don't use the fragment container view. But when using a ViewPager, we actually have to consider a few different things. So firstly, it's useful to think of a ViewPager the same way we think of our traditional adapter views or even the recycler view, because we have the same or similar functional components. There is the view itself, and then there is an adapter that provisions the components that get displayed. So in the adapter view, in the case of the adapter view, we have an adapter that generates views. In the case of ViewPagers, again, despite the name, you always see them being used to display fragments. The adapter provides the fragments that get displayed in the ViewPager. And there are some considerations that are at play here. So first, let's just clean up the code that we don't want. So I'm removing the fragment transaction, and I am removing the fragment container view from the activities layout. Now, what I'm going to do is, in my activities layout, I'm going to replace that fragment container view with an instance of ViewPager2. This 2 is important. So in the IDE, right at this point, when you start to type ViewPager, ViewPager2 is the only option you have. So it's very straightforward here for us to add a ViewPager element to our layout. So adding that ViewPager, it's filling the screen, so I should be able to just add constraints the old-fashioned way. And I always want to make sure I set my layout to match constraint, because it takes a fixed size, which is in most instances not what you want. So I'm just adjusting that accordingly. And I'm going to give this an ID. I'm going to call it ViewPager2 just for simplicity. It's not the second ViewPager. It's the first instance of the view type ViewPager2. Now, why is there a ViewPager2? It is called ViewPager2 simply because there was once a view called ViewPager, which we could, I guess, for comparison, just call ViewPager1. Of course, the original name was just ViewPager. They didn't know they would have a second one. And the ViewPager was replaced by ViewPager2 because of some issues relating to the implementation of ViewPager. So the ViewPager itself had its own little user concerns or usage concerns. But the main issue, as I see it, related to the adapters that were originally used with the first ViewPager. There were two different types of adapters. One that was used for simple cases where you had a fixed number of fragments that never changed, and a second type of adapter where the number of fragments could change dynamically, grow or shrink. And regardless of which one of those fragments, those adapters you were using, you would maintain your own collection of fragments. You would have a list or an array list or something to keep track of your fragments. Having this separate collection, though, would oftentimes cause problems with references because of how fragments are managed in the framework, in the Android framework. Specifically, or certainly one thing to be mindful of is the fact that in the same way Android can destroy and recreate activity instances where the new instance is meant to replace the old instance, and it should be invisible. Fragments are also managed in a similar fashion, where a fragment might be destroyed by Android and a new instance created. Well, it so happens that if you are maintaining a collection of fragments yourself in a list, you could run into issues where Android has created a new fragment instance to replace the fragment that is being displayed in whatever context, in this case, a ViewPager. But your collection still has a reference to the old fragment. So your attempts to manipulate the fragment that is being displayed, you don't see those changes being reflected because you might be referencing the fragment that is in the collection at a specific index, thinking or hoping that it's the one that's being displayed, but it isn't. That's a whole new instance. So it added all of these complexities where we had to keep track of which fragment was being displayed, make sure that we had the updated references. So ViewPager2 was introduced as a way to address these. It fixed some pain points just having to do with the ViewPager's implementation, but it also addressed the issue of the adapter. And it basically works like this. So first things first, we get a reference to our ViewPager. So let's just keep it simple. We'll say our ViewPager2 is a ViewPager2. Now here, unlike when we were dealing with the UI for building our layout, when we're typing code as it stands right now, when you're typing out the ViewPager, there are two options available to us. There is the ViewPager and the ViewPager2. So now we have to be specific because in our code, we will see ViewPager. We have to make sure we select ViewPager2. That is when we are specifying the class type in any context. Make sure that we get it right. Do not select the ViewPager by accident. That is a different view, and it will cause all types of issues and class cast exceptions or functions being missing, what have you. So just make sure that you pay attention to that. All right, and now we can take reference our ViewPager. Now, my ViewPager, or my ViewPager2, is going to take an adapter. The adapter I'm going to give to my ViewPager is going to be an anonymous instance of a class called FragmentStateAdapter. The FragmentStateAdapter takes an argument for its constructor. The argument it takes is a reference to an activity. It may also take a reference to another fragment, but let's just focus here. What's really happening here is that it is taking a reference to an object that is able to host and manage fragments. Specifically, something that has a fragment manager. This is the difference between this new adapter that the ViewPager2 uses and the two adapter types that were used with the old ViewPager. And you may still come across that old ViewPager if you look at legacy code out there. So, it's good to be mindful and aware of sort of how it all worked. So this adapter, basically, instead of having you, the user, manage your own collection of fragments, it basically says, I already have a way to deal with managing fragment collections, and that is the fragment manager. The fragment manager that is built into the parent, built into the host. So in this case, the activity, whenever you are attaching fragments or managing fragments, the fragment manager is already holding on to the list of fragments that are currently attached. And it does the proper updates for references if a fragment is ever destroyed or recreated. So we don't have to reinvent the wheel, and we don't have to add complexity by trying to keep our own collection and make sure it's updated. This new adapter at least, just says, don't worry, I'll use the fragment manager and I'll do all my work there. So I don't have to do it myself. I, the programmer, I don't have to do it myself. So the FragmentStateAdapter is basically taking a reference to the activity here because I'm in an activity. I implement the functions that are a part of this FragmentStateAdapter. And here we have the two functions that I need to complete, which are relatively trivial. The first is a question of how many fragments does this adapter have access to? So we're going to, at this point, put a fixed number. And I'm going to say this FragmentStateAdapter can generate 5 fragments. We're right now looking at the simple case where we have a fixed number of fragments, i.e. 5. And after this, we're going to look at the case where we have a dynamic number of fragments, and we're going to see how that works. So right now, we're just saying we have a single fragment. Oh, sorry, we can do 5 fragments, so a fixed set. So that's the first function, get item count. The second function is called create fragment, and you're passed a position as an argument. This is where you put the code for how a fragment should be created. So remember, the whole job of an adapter is to generate something. In the case of our adapter views, the adapter generates views. In the case of a FragmentStateAdapter, we generate fragments. So again, you see the patterns show up in both places. So in our scenario, what we're doing is creating a fragment using our text fragments new instance function. And we need to pass it some text. I'm going to pass it, in this case, I'm just going to pass it the argument, the position argument. So that'll be a number. And this is probably going to start at 0. Not probably, it will start at 0. So I'm going to add 1. So we don't see 0, we see 1, 2, 3, 4, etc. 1 for the first, 2 for the second, what have you. So that's a text that is being passed in to the fragment's new instance. I'm also just going to shorten this just so it looks nice. This is now complete, but if you just have a simple return statement, as I do here for any function, in Kotlin you can replace that by just saying the function is equal to. So I'm going to remove everything up to and including the colon, and I'm going to say this is equal to 5. Similarly here, I'm going to take this line, I'm going to cut it. I'm going to remove everything, and I'm going to say this function is equal to this line of code. All right, so this is a way to, it's a nicer look for simple functions if I don't have to do a whole lot of code. If I can simply reduce my function body to a single statement, to a single expression, then you can actually just say, well, the function is equal to that. All right, so this is my current implementation, and what does this give me? So now when I run my code, the adapter, because it says it can generate 5 views, 5 fragments, I'm able to get 5 fragments here, and each one is now displaying the number for its position. So I now can swipe. So I'm performing the swipe function here. This is what the user would do with their finger, and I can get up to 5 fragments. If I try to go beyond that, I get nothing. And I can go all the way back. Now, there's some stuff happening here. The small number of fragments I have is probably not impacting it in any way, but I want to point something out here, and that is, you'll recall that the fragments, Android has this ability to destroy and recreate fragments. Well, it can do that with ViewPagers as well. In fact, once a ViewPager is quote-unquote far enough, once a fragment is far enough away from the current fragment being displayed, you may find that the fragment is in some ways deallocated. It's destroyed and may be recreated later when the user starts to swipe towards it. It's not necessarily similar to the recycle pattern that you might find in adapter views, but it is an optimization. It's to make sure that the ViewPager's adapter is not just maintaining tons and tons of fragments in memory at the same time. So as you move away from a fragment, it might be destroyed. The reason this is important is my current fragment is only implemented in such a way that it displays the initial value, which means that every time a fragment gets destroyed and recreated, it's taking the initial value and displaying it here. That's fine for this very simple fragment. The value that's passed in is the value that it should always show. But if this was a fragment that I was able to manipulate and change its initial state to something else, and then I was to swipe away and that fragment gets destroyed, going back to the fragment would be problematic because it would go back to the original value. It would reset. So if that were the case, I would need to make sure that I come to my fragments implementation and I implement the necessary state management steps. So for me, that would be starting with overriding onRestore instance state. Onsave instance state, rather, to save any information, and then extract that data in any scenario where I am potentially looking at taking the initial data. So in my case, I'm doing it in onCreate. So I would need to modify this logic to make sure that I first check if there is updated state information here. Is there saved instance state? And if there is, use that data. And if there isn't, use the initial arguments, the initial values that were passed in. So either or. And that would ensure that when I go back to a previous fragment, if I had changed that state, it's not forgotten and reset, and I will see the original value. I'll see the updated value. All right, so this is how our fragment operates, our ViewPager operates with a collection of fragments. Now, what we're going to do here is just show you what we would do if this was not a fixed set of fragments. What I'm going to do is I'm going to add a button. And I will call this button, and we're having very bad rendering issues here. So I have my button here. I'll lift it off the bottom of the layout, and I will attach my fragment, my ViewPager there, and put some space. All right, so this button is going to be the add button, and it's what I'll use to add a new fragment instance. And I will just change this to add. We're using fixed string values, and that's okay, just for interest of time and for testing. So what I'm going to do with this add button is this. I'm going to give it an on-click listener, but I think you already knew that part. And what I'm going to do is every time I click this button, I want to add a new fragment. So in the case of adding a new fragment, as you'll recall, because we're not managing the collection of fragments ourselves, I don't actually create a new fragment and then hold it. If I want to add a new fragment, I just tell the adapter that it can create more fragments. So whereas here I have this fixed value, 5, what I really need is a property that can be changed. So I'll create a var, because it needs to change, and it probably should be a private var. We should get in that habit. Number of fragments, and I'll start that out with the number 1. Number of fragments. And then when I click the button, I will simply increase number of fragments. Now that is telling my adapter that it can generate more fragments. However, I have one additional thing I will need to do. I will need to tell my adapter that there is new information available. And I do that by calling the notify function. So I'm going to take my ViewPager. I'm going to get a reference to the adapter. Just to, for simplicity, I'm going to have to cast this. Tell it that the adapter is a fragment state adapter that has to do with how the object is actually being referenced. And I'm going to call notify. I can call notify dataset changed. I can call notify item changed and specify the position if I know it. And it so happens that I do, but let's just use the broad notification where we just say, I'm calling notify dataset changed, letting it know, okay, something is different. Now, when I run this code, what I'll get is the ability to create new fragments by just hitting add. So right now I'm at 1. I cannot scroll left or right. If I hit add, now I have a second fragment. Hit add 2 more times. I have up to 4. Again, so the fragments are being created in an ad hoc basis as needed. As I'm scrolling over, fragments are being created. The create fragment function is being invoked. It's a callback. I'm not the one calling it. I just implement it. I'm just telling it, how do I create a fragment when one needs to be created? And get item count is how many fragments can be created. So that's what we have here. And I could do one last piece of one change to this. And that is whenever I do create a fragment, I want to jump to that newly created fragment automatically. So I have a couple of ways to do this. I can just set current item to be whatever value I'd like it to be. But there is a nicer way to do it. I can call set current item. And set current item is an overloaded function. There are a couple implementations of it. There is one that takes the index and one that takes the index that you want to set as the current item and the value for smooth scrolling, a Boolean value, whether or not it should scroll over to that element or if it should just do a smash cut, should it just jump to it. So in this case, the element that I want to scroll to when I create a new element is number of fragments minus 1 because it's an index. And I'll set true for smooth scroll. That tells Android to just slide over to that value. So this final version of my ViewPager application looks like this. So when I hit add, I jump to that value automatically. Even if I was over at another value 2 and I create a new one, I jump to that. So I'm always looking at the newest fragment that I created. All right, so this is the basics of using a ViewPager or a ViewPager2. Again, if you hear me say ViewPager at any point in this video, except when I was doing the compare and contrast, I'm referring to the newer ViewPager2 and the accompanying FragmentStateAdapter. This is the adapter that works with ViewPager2. The previous ViewPager instance, ViewPager class, used different adapter types depending on if you were going to have a fixed number of fragments or a dynamic number. And those adapters also required that you manage the collection of fragments yourself, which was problematic for a lot of different reasons. But this is the basic use case. As your fragments get more interesting, you may have to sort of expand on this, learn more about the view pagers, learn more about the different callbacks that can be invoked, such as being notified when a scroll occurs. These are all things that you can, these are all events that occur with the view pager, and you can respond to those things. All right, hopefully this was useful.